A pleasant evening, one and all present here. On behalf of our K.S.Rangasamy College of Technology, I warmly welcome you all to the 6-day online faculty development program on disaster risk management analysis and mitigation. We are gathered here today to delve into an incredibly important and timely subject that concerns not just us, but the entire world. This event marks the beginning of an enriching journey, and we are honored to have such distinguished personalities with us. Over the next few days, we will explore vital insights into an disaster risk management, and I am sure it will be an inspiring and informative experience for all. To kick off this session, it's my pleasure to invite our beloved HOD, Dr. P. Mahesh Kumar, Associate Professor and Head of the Department of Civil Engineering at KSRCT, to deliver the welcome address. Please, sir.
A very good evening to one and all present here in the today's meeting. It gives me immense pleasure to welcome you all for the 6-day online Atal FDP on Disaster Risk Management Analysis and Mitigation, organized by the Department of Civil Engineering, K.S.Rangasamy College of Technology. With the blessings of our founder chairman, K.S. Raya, it is my privilege to accord a very cordial welcome to our chief guest, Dr. A. Sudhakar, Managing Director, Dimension Construction, Coimbatore, whose gracious presence adds an inspiring touch to the occasion. I am very grateful to welcome our chairman, Sri R. Srinivasan, KSR Educational Institutions in absentia. It's my privilege to welcome our beloved and dynamic principal, Dr. R. Gopalakrishnan sir, whose vision and foresight helped us to see this initiative translate into action. I wholeheartedly welcome our vice principal, deans, directors, heads of various departments, and faculty members from KSRCT, especially the coordinators, Dr. S. Ramesh and Dr. J. Abdul Bari. It's my pleasure to extend a hearty welcome to all the participants from various parts of our country for the 6-day Atal FDP. Thank you for the opportunity. Thank you all.
Thank you, sir, for your insightful and warm welcome. Next, I am honored to introduce a leader who has always inspired both students and faculty with his vision and commitment to excellence. I welcome our energetic and dynamic principal, Dr. R. Gopalakrishnan, KSRCT, to deliver the principal address. Please, sir.
Thank you, Musi, with the blessings of our founder, Dr. K.S.Rangasamy. At the outset, I would like to convey my sincere thanks to AICTE for giving us an opportunity to conduct this online FDP with the title Disaster Management and Mitigation, Disaster Risk Management and Mitigation. And the chief guest of the day for the inaugural function, our well-wisher, Dr. Sudhakar, and the organizing team and head of the department, the principal investigator, Dr. Ramesh, and the faculty members from various institutions and industries, and all the other participants. Good evening, all of you. It's my pleasure to be, in this inaugural event of Atal FDP. Hope I'm audible. Very specifically, disaster risk management and the mitigation. And as you're all aware, this FDP been organized by our civil engineering department. So mostly any disaster, probably the role of civil engineering is very important. There are two management. One is preventive management and post management. Here, probably the titles also I will be able to see all the 5 days and the 6 days meticulously. Our team has done their work and make sure this online FDP will help the participants to plan something, not only for the academic people, it is also for the people who are working in the industry. So a few things probably I wanted to know, highlight related to the title, disaster risk management, because in our country, even 2 days before, there was a disaster. So disaster means it's not only a natural made, even it is in a man-made disaster also. So just 2 days before, you're all aware, there was a disaster in Delhi, just because of announcement, the change of platform, 16 to 18 or 18 to 16. So we unnecessarily lost 18 people. It's a fatal accident. It's again a kind of a disaster. So how to mitigate these kind of problems when suddenly something happens? So some plan B always supposed to be there. So for that we have to have a preparedness. So when you do a design, because there are two things. One is man-made disaster or natural disaster, as I said. So probably we have to have some kind of an analysis, risk analysis, again, pre-analysis and post-analysis. And based on that, we have to mitigate. So obviously, any disaster. So main objective of this management and the mitigation, to mainly to focus to save the valuable, highly valuable the human life. So that's very, very important, because once we lost we cannot bring back. It's not a machine. We can do something and bring back the life of any individual. So the disaster management, our focus is more on life-saving moment, and how we will be able to save the life of the human being. That's one of the thing. And even a lot of simulation tools are there for the natural disasters. And one such disaster, we call it as an earthquake. And more than that, now recent days, we are also encountering or witnessing landslides. So that's the reason the geotechnical or geotextile applications also being implemented. So there also we have a lot of the software studies also been taken place. And with that, yes, obviously, we'll be able to come out with some kind of solutions, and we'll be able to make sure we'll be able to do something for the country and something for the society. So that's what I wanted to say. I'm not sure whether any of you come across this specific news. And another recent disaster yesterday, I just know, I'm not sure about the country. It's in a gold mine. It's a gold mine. 56 people, again, because of the landslide or something happened, some disaster happened. 56 people died. It's all news came in the newspaper or in the online news. So that's the thing. So whatever the activities, the mitigation and the management. So we have to take care uh, to ensure we are saving the human life. This is what I wanted to convey. It's my request to all the engineers. It's all, engineers can do wonders. So with that, I once again thank our today's chief guest, Sudhakar sir, for being here and giving us continuous support to our K.S.Rangasamy College of Technology, and also thanks to our AICT, All India Council for Technical Education, for extending always their support. And these kind of FDPs obviously will be able to help the faculty to understand different techniques, understand different problems, and how you can, or an individual, you can do some kind of an extensive application-oriented research rather than going with an academic research. You can also make our students to do some kind of a research, even for our small lake nearby water body or anything for that matter. We can do some kind of a process, and that will again help the country to progress. So thank you all, and I request all of you to attend regularly and interact with the experts. We will be able to gain knowledge and the networking opportunity for all of us. Thank you, and over to you, Mercy.
Thank you, sir, for your motivating and thought-provoking address. Your leadership continues to inspire us all in our academic pursuits. Now, moving on to the next segment of our program, we are fortunate to have Dr. S. Ramesh, Professor of Civil Engineering and Coordinator of this program, to have a few words about FDP. Please, sir.
Thank you, Emosi. Good evening, everyone. Is audible? Yes. Is audible? Good evening, everyone. It is a great honor to be here before you today and talk about the importance of faculty development program in enhancing the knowledge and skills of educators. These programs are not just a training session, they provide opportunities for learning, research, and innovation that help us grow in our profession. The Atal sponsored FDP on disaster risk management analysis and mitigation is especially relevant today. With climate change and natural disaster happening more frequently, understanding disaster preparedness, mitigation strategies, and resilient infrastructure is essential. Over the next few days, experts will guide us through key areas such as early warning system, earthquake-resistant material, and disaster risk reduction technologies. We are privileged to have a distinguished panel of resource persons, including experts from NITs and reputed institutions, industry professionals from leading organizations. This FDP has received a lot of response with 300 applications from faculty members across various institutions. Due to limited seats, we have carefully selected CIT participants based on their specialization and relevance to this theme. This ensures that all participants can benefit fully from the sessions and apply the knowledge effectively in their teaching and research. I sincerely thank Atal Academy, AICT, our management, principal, distinguished speaker, and all the participants.
Dr. Ramesh, probably you have to give the final remarks. Organizers, probably you can mute the attendees and you can give the permission to the presenter, including the MOC. You can move them in such a way. Organizing team.
Thank you, sir. Thank you, sir, for your enlightening presentation about FDP. Now it's time to know more about our estimate chief guest, Dr. A. Sudhagar, Managing Director of Dimension Construction, Coimbatore. I invite Kavya M to introduce our chief guest.
Believe you can, and you are halfway there. We are honored to have Dr. A. Sudhagar, a renowned expert in architectural, structural engineering, and project management, as our chief guest with over 2 decades of industry experience. Dr. Sudhagar has made significant contributions to the field of civil engineering, boosting an impressive portfolio that includes a doctorate in civil engineering, as well as extent as a former regional head technical South and West India for ACC Cement Limited. He also an approved third-party consultant for a Ministry of National Planning, Housing and Infrastructure, Maldives. Has an held key position as a chairman of the Association of the Consulting Civil Engineers India, Coimbatore Center, and immediate past chairman of the Indian Concrete Institute, Coimbatore Center. As a chartered engineer, Dr. Sudhagar has successfully completed projects in India, including UAE, Maldives, Germany, China, and Malaysia. And we have looked forward this presence and insightful address. Thank you, everybody.
Thank you, Kavya, for your nice introduction. Now I hand over the session to our chief guest. Please, sir.
Thank you, MOC, esteemed principal, and colleagues of the Department of Civil Engineering and dear participants. Good evening, all. I think you are having 6 days of well-planned interaction with various experts on a very, very important and a relevant topic. Even today, 4 o'clock, we had the Prime Minister tweeting about the earthquake in Delhi. We are yet to hear newspaper reports on them, but today morning we had a mild tremor in New Delhi, and we heard that the Prime Minister has tweeted immediately on that. So we are discussing this in a very relevant scenario. The principal in his address also was mentioning about the disaster which happened in the gold mines of Mali, and 2 days ago we had the stampede in Delhi. Probably a month ago we had a stampede in uh, Tirupati. So every week we are hearing some kind of an accident, which is either man-made or it is natural. So as engineers, as I would begin any of my lecture with the students, I always feel the word engineer should be taken in the right perspective. I learned that this word engineer is actually derived from a Latin word called ingenious, meaning genius. So the role of engineers is to solve problems, not once they have occurred, but uh, imagining their occurrence. Engineers have to solve the problems. For a civil engineer, if he creates a building, he has to imagine the collapse of the building and give a solution which will make the building resilient, and will avoid the collapse. Similarly, each branch of engineering will have to imagine a scenario and give a solution. I think that is the one of the primary trait an engineer should have, irrespective of what branch he belongs to. Uh, and today we are here to inaugurate the FDP on disaster mitigation, risk management and mitigation. I think this all the experts will not take it like we are addressing a group of faculty. In fact, we are actually addressing hundreds and thousands of students through a group of faculty. So I would place a request in front of all the participants to pay close attention to the deliberations, and probably come out with small experiments and case studies and monographs of whatever is being discussed, and create a toolkit for the students. All these FDPs should not go only as an information, but it should go as an actionable point to the students, wherein they can create small models, small publications, small posters or pamphlets of the do's and don'ts. Small calculation tools could be as simple as an Excel sheet, or it could be a well-written Python program. It could be an app, whatever is uh, it is, whatever relevance it will have to the topic. So I congratulate KSR College of Technology, and especially the Department of Civil Engineering, for having uh, got the chance from AICTE to conduct such a wonderful faculty development program. I would say disaster mitigation or management. I would like to quote mm, a very famous Tirukural, which says, "பொருள் கருவி காலம் வினை இதனோடு ஐந்தும் இருள் தீர எண்ணிச் செயல்," which means it
ये
talks
वाला
about
वहां
the
पेपर डाल के
பொருள்,
बिछा
raw
दे।
material, karuvi, the machinery or the tool, kalam, the period, செயல், the action, and idam, the right place. So if you are conscious about all these five aspects, then your disaster mitigation is already in place. So I think we should all take cue from this very nice Tirukural, Kural number 675 from Porutpal. So with that, I would not like to be very customary on the inaugural address. I am raring to give you a lot of information through my presentation, which probably is the first session of your FTP. But I should give you a kind of a premonition also. For the 6 days, I think you are going to talk about a very negative subject, which is disaster. So I think it is very important for you to stay positive and see disaster management as a positive subject, because you are not talking about disaster recovery, post disaster recovery. Of course, there are few topics which will touch on that also, but we are more proactive or preactive in identifying the possibility of a disaster, or simulating mentally the scenario of a disaster, and finding out solutions which will help us reduce fatality and loss of property or ecosystem. So it is very important for us to stay positive, and it is very important for us to take cues from the deliberations and come out with actionable points, actionable publications on awareness about disasters. You can develop a complete toolkit. You can have a complete template about disaster management, probably something in your campus, something for your locality, something for your district. I would also prompt you to study the various disaster mitigation models available, especially from the states of Gujarat and Odisha. Odisha, I think, is ranked number one in terms of disaster management. So there are a lot of information available over the net. If by chance there are faculty members attending from Odisha, you can contact them also and get the relevant information. So, with this, I wish all the best for the FDP, and I look forward to interact with you with my formal presentation. And I look forward for the organizers to send me a list of actionable points taken through the FDP, so that it is not to police you. If at all there are areas where I can pitch in with some information which can be helpful to you, I would be glad to do this, because doing something here is doing something for the whole nation, not only for the civil engineering students, it is for the entire community as such. So I wish we all take these deliberations very seriously as responsible citizens of the country and make this FDP a grand success. Thank you. Over to the MC.
Thank you, sir, for your insightful address and for your sharing invaluable industry perspectives. Your words are sure to motivate us to talk and what we learned here into the real world. Now, I request all the participants to switch on the camera for group photo session.
Bari sir, please unshare your slide.
And share and video also to be enabled for the participants.
Enable the video.
Sir, enable video.
Enable the camera.
I think you have disabled the video. Okay.
So it has been enabled, sir. Participants are requested to switch on your videos. I request all the participants to switch on your videos.
As we come to the end of this inaugural session, it's my privilege to invite Dr. J. Abdul Bari, Associate Professor of Civil Engineering at K.S.R.CT, to deliver the vote of thanks. Please, sir.
Good evening to everyone present over here. It's my privilege and honor to propose the vote of thanks on the special occasion of this inaugural ceremony of 6 days online AICT training and learning Adult Academy FDP program on disaster risk management, analysis and mitigations, organized by Department of Civil Engineering, K.S.Rangasamy College of Technology. First and foremost, I extend my heartfelt gratitude to our chief guest, Dr. A. Sudhagar, Managing Director, Dimensions Construction, Coimbatore, for gracing this occasion with his esteemed presence. His inspiring words and valuable insights have set the perfect foundation for this FDP. I am profoundly grateful to our principal, Dr. R. Gopalakrishnan sir, K.S.Rangasamy College of Technology, for delivering the principal address and for his continuous encouragement and support in organizing this FDP. Sir, your presence and motivating words have truly enriched these events. Thank you, sir. A special note of appreciation to Dr. S. Ramesh, Coordinator for AICT Atal FDP, for his dedication and efforts in making this FDP a reality. His meticulous planning and coordinations have played a crucial role in ensuring the success of this program. I extend my sincere thanks to Dr. V. Magesh Kumar, Head of the Department of Civil Engineering, K.S.Rangasamy College of Technology, for delivering the welcome address and setting the right tone for this event. Your warm welcome added a great start to the session. Thank you, sir. A heartfelt appreciation to the Atal Academy for sponsoring this FDP program and for providing us with this wonderful platform to gain insights into the disaster risk management. I also take this opportunity to express my gratitude to our management, faculty members, and supporting staff for their unwavering support in making this event successful. A big thankful to all the participants for their enthusiastic presence. We hope this FDP will be a fruitful learning experience for all, and we look forward to engage discussions and knowledge sharing in the upcoming sessions. Finally, I also like to have my sincere appreciation to the organizing committee, technical support team, and everyone working behind the scene for this dedication and efforts in ensuring the smooth execution of this event. Once again, thank you all. Wishing you all successful and enriching FDP. Thank you all.
Thank you, sir, for your kind vote of thanks. Thank you, sir, for your kind vote of thanks and for concluding this session on a such positive note. With that, we conclude the inaugural session of the 6-day online FDP on disaster risk management and analysis and mitigation. I would like to express my deepest gratitude to all our speaker, participants, and organizing team for making this event possible. I hope all you enjoy the session and gain valuable knowledge over the next few days. Thank you once again for being here. I wish you all fruitful learning experience. Thank you for this wonderful opportunity.
Dear participants, kindly stay in this link. Now the session will be going to start. Sir, Sudhakar sir.
Yes, sir. I'm sharing. Just
Okay, sir. Okay, sir.
Is my screen visible, sir?
Noted, sir.
Not visible, huh?
Yes, sir. Noted, sir.
You allowed me to share, no?
Yes, sir. You are a presenter, sir.
Give me a minute, sir. Now, sir?
Still not yet came, sir. Sir, can you send your PPT, sir? You will share it.
But I don't think it will load because it's a big file with lot of
Okay,
photographs.
sir.
Give me a minute, sir. How come we are not able to? Screen, I choose a window.
So you
I'm
share the
actually
entire screen,
sharing.
sir.
I'm sharing the entire screen only. And now I'm going to the PPT. Now I'm into my PPT full screen.
But it's
Is
not
it taking
visible
a
here,
lag,
sir.
sir?
Some network issue, I think so. It's a bit due to large.
No, if it is a large file also, I'm sharing slide by slide only, since it's online. Maybe the organizer is also, Dr. S. Ramesh is also presenting. Maybe he should stop sharing and then I should do.
Sir, we have stopped, sir.
Is it?
Since it's organized, sir. Just a minute, sir. Search.
Maybe have only one presenter, probably.
Sir, now you just check it, sir. I will.
No, now I'm not able to activate
Just a
that
minute, sir.
share.
Just a minute, sir.
I see there are 7 presenters here.
Sir, just a minute, sir.
Yeah.
Sir, now you just try it, sir. You are a presenter, sir.
Okay. I have clicked share.
Yeah, it's now visible. Processing, sir. Yeah, your entire screen is visible, sir.
Now my PPT is visible.
So your screen is visible. Yeah, PPT is visible, sir.
Yeah. Thank you, sir.
Thank you very much, sir.
So I think we have time till 8 o'clock, is it, sir?
7:30, sir. Up to 7:30.
So we
8,
hardly
8, sir.
have
Up to 8. Up to 8, sir.
Okay. So what I'll do, I'll take up to 7:50 and we'll have 10 minutes for interaction.
Oh, okay, sir.
6:40 in my watch now. So
Okay, sir,
welcome
fine,
back, participants. As we have set the tone for very important deliberations on disaster risk management and mitigation. Let's understand the topic very deeply. What is a disaster? When we talk about disaster, it is very usual that we only think of big natural calamities. Uh, but the Wikipedia defines disaster as a sudden event which leads to loss of life, property, or societal or biospherical well-being, be it with a larger geographical impact or a very small geographical impact. Which means it need not be loss of life always. It could be loss of certain species of herbs. It could be loss of. It could be the extinction of certain species. It could be discrimination of certain creed or caste or whatever. So all these are actually disasters. It is a sudden event which leads to loss of life, property, or the societal or the biospherical well-being. For disasters, precautionary measures are not always possible, or at least not 100% effective. You can only guess, or you can only anticipate a disaster, and you can have some preparedness, but you cannot 100% mitigate it, because you never know at what scale and what time it will strike you. And you can't be always on your toes only looking for disasters, because all governments, all families, all individuals have to take care of their day to day functioning also. So you cannot be 100% prepared for a disaster 24/7 into 52. So that is what it is. If you have to see examples of disasters, here you have the list. It starts from a fire accident, oil spillage in the water body, a road accident, earthquake, tsunami, cyclone, drought, structural collapse of the built environment, pandemic. We had a very good example from the COVID pandemic. Malnutrition. A few years ago we were talking so much about a country called Somalia, where children and the general public were affected by malnutrition and starvation. Volcanic eruptions, cyclones, tornadoes, floods, and nowadays stampedes is also being highlighted in the list. So disaster is always a possibility, but it strikes without a warning. These are the types of disasters. You can of course, it depends on the perspective or yardstick which you use to classify disasters. These are some popular classifications of disasters. One is the natural versus man-made disasters. Few are predictable and unpredictable disasters. Predictable are those like stampedes, which there is a possibility if there is a large gathering. uh, maybe a tsunami is sometimes predictable, because the moment you record a seismograph, or if you see a seismic activity in some island, then probably you can calculate or forecast whether this will lead to a tsunami or not. So this is one more perspective of classifying disasters, which is the predictable and unpredictable. The third perspective would be long term and the short term. There are disasters which are long term. For example, the El Nino, the climate change, the melting of the ice caps. These are all long term disasters. There could be short term disasters which happen suddenly, and the effect is existing only for a short period of time. Natural disasters can be further classified into geophysical disasters, which primarily is from the basis on which, or the uh, cause of the disaster itself. So geophysical disasters are earthquake, volcano eruptions, landslides, etc. You have the next type, biological disasters, which is the epidemic or the pandemics, other infectious diseases. For example, yellow fever and malaria in Africa is a kind of a disaster. It's actually a disaster only, but they are not epidemic or pandemic in nature. But once you go there, you are susceptible to contact the disease. Therefore, that is why the governments are insisting on uh, yellow fever injection, preventive vaccinations for travel to areas like this. Lifestyle diseases, like for example, obesity and uh, cardiac problems, uh, they are also disasters. These are all biological background disasters. Insect bites. There are a lot of areas, especially in the Amazon, where you have breeds of poisonous insects and reptiles. So if you are doing some activity there, then you might encounter a disaster due to insect bites also. There are meteorological disasters, again a subclassification of natural disasters, which are local storms, local floodings, tropical and extratropical cyclones, tornadoes. These are all happening on the land. wherein hydrological disasters are mainly due to water, which is tsunami, flood, hailstorm, landslides, etc. The final one would be climatological disaster, which is the heat wave or a cold wave or a drought or a forest fire which happens due to the El Nino effect or the peak spike of summer, etc. So natural disaster itself will have a lot of subclassifications. There are many types of man-made disasters, which the most popular ones are the industrial accidents, and I think they constitute the maximum population of the man-made disasters. Usually, it happens in industries where safety norms are flaunted, or not enough precautions are taken, or not the systems are not designed to take such overloads or out of the ordinary loadings on the system. There could be chemical spills uh, from logistic vessels or even inland. Oil leaks from oil and pipeline. If you know your students who are working in the Middle East and all, they will talk more about oil leak kind of accidents, which could end up into disasters. We have fire, whether in a domestic environment or an industrial environment or a commercial environment. So fire is also a very popular man-made disaster. Not discounting war. Now the famous Gaza Strip is now having a disaster. Ukraine is having a disaster. Russia is having a disaster. So this is also to be considered as a disaster. Crime. Now for the past few months we have been talking about crimes against children. These are all also disasters, but they are all on the society. It doesn't. It is more on the society or the policy level kind of a mitigation. Terrorism is, of course, also an disasters. So the perspective of relating or studying the term disaster should not be limited to only the natural calamities, but it has got a very broader perspective, and that is what I have been trying to share with you through these slides. So disasters could be anything. The effects of disasters could be very small or non-impactful or non-significant. Sometimes it could be very catastrophic also. It could be long duration, such as crop failures, malnutrition. You would have heard of, I think there was few films also which were the feature films which were taken on that. The locust, the grasshoppers migrating over the tropical belt. It started killing or damaging the entire agriculture on its way. So the locusts destroyed every crop which was encountered during the migration. So these were all long duration disasters, which has to be mitigated by proper policy level planning and actionable points. Global warming as such is a disaster. We have been trying to talk so many things about it. We are talking about green buildings. We are talking about green certifications for buildings. We are talking about eco-friendly practices in almost all human activities, like packaging, in logistics, in public transport, in food, in agriculture, everywhere. But these are all basically long-term mitigation techniques which we have to meticulously follow and make it more effective. The impact of disasters could be on primarily on medical, because the first thing which you have to be ready with is the medical emergency mitigation. So once a disaster strikes, we are all first and foremost concerned about the loss of life and saving the injured. So the medical sphere is first impacted whenever there is a disaster. Then comes the economical impact of a disaster. Once a disaster strikes, it is very eminent that it is very imperative that the general working or the normal working routine of that particular zone is going to get affected, and therefore it will have an economical setback. So unless there is a recovery package or a bailout package planned for that, you will not mitigate the disaster very effectively. So it will have a medical impact, it will have an economical impact, it will have a social impact, because people affected by disasters, for example, if you had visited any of the relief camps for the refugees from Sri Lanka, you can see this. Their psychology is yet to be normalized. So they still have that stigma, and therefore they are not able to perform or mingle with the normal society. And since they are already cordoned in a special zone, they have their own problems. So social impact is there. Environmental impact, yes, of course. We had a I think 6-7 months ago, we had a disaster in South India, especially the Wayanad region. You would have heard about the landslides in Wayanad. So we had a small landslide in Tiruvannamalai. So these are all environmental impacts. Though, so the landscape is going to change, the slopes are going to change, so the water paths are going to change. So accordingly, there will be an impact in the forest line and the flora and fauna around it. There could be political impacts because of disasters, what we see in Russia, Ukraine, Poland, etc. There could be administrative impacts also. So once a disaster strikes, the government, whether it is the local body or the state government or the central government, has to have a system in place, a mechanism in place, the machinery in place. So the administrative machinery has to realign itself and act very fast and very specially to mitigate the disaster. So disaster management, yes, we saw about predictable and non-predictable disasters. There is a shocking statistic available which says that globally we have lost 30 lakh lives in the last 20 years due to man-made disasters alone. So this is huge. This is criminal, which means the stakeholder society, especially the engineering society, uh, we are actually culprits to it. Uh, Not as an individual, but as a whole group, we have failed to bring in very resilient systems for disaster management. That is why we have lost 30 lakh lives of our own brothers and sisters. So the primary objective of disaster management would be, yes, obviously minimizing the loss of life, and only next would be preventing the loss of property. So the life stands first, be it the life of humans, of course, that is first, and also the life of animals or the fauna around the affected area. There are secondary objectives which are long term for disaster mitigation also, which is about the rehabilitation of the affected area. Now, when we talk about management, we should talk about preparation also. We have seen a lot of examples of being prepared for floods, especially Mumbai, the west coast of India, and especially Maharashtra, from starting from the north of Goa. They all gear up for embracing the monsoon. Every street has got a disaster mitigation team. They overhaul their equipments to cut tree branches in case they fall down. They have rescue rafters in place. They train the rescue teams. In fact, there are a lot of uh, training which happens from the lessons learned from the previous flood. So they have created a lot of booklets and small videos on the do's and don'ts during a flood. So this is one example. I'm taking only flood as an example so that we can relate it more easily. So preparation is all about having the tools in place. I was talking about the Tirukural in the um, inaugural session. It's having the right tool, right material at the right place with the right team, and putting it to effect at the right time. So This is what the preparation is all about. Of course, there are many evolutions which has happened flood after flood. We have learned so much. The first aid systems have improved, the evacuation systems have improved, and the rehabilitation systems have improved. For example, we have now airlifting facilities in place, wherein previously we didn't have that luxury. Now we also have airlifting of people. We have the paramilitary forces and the military forces coming up with lot of inflated rafters to evacuate people during floods. So these are some perspectives of preparation. Uh, the moral which I would like to get through to the upcoming students through you is like disasters cannot always be fought or avoided. You don't fight to avoid a disaster. You only prepare yourself to respond during a disaster. So, what is more important is gauging what you have, meaning having a status quo of the resources you have, channelizing them, and you minimize the response time. For example, there is a fire in a building. You should ensure that the firefighting mechanism or the firefighting team can reach the building in the quickest possible time, which means you have to be sure about the communication from the area of disaster to the response team, and the logistics from the location of the response team to the affected area has to be in place. You have to plan the logistics or the elimination of the bottlenecks in the logistics. So this is very important. So disaster mitigation is all about response planning, not about first aid or giving food, rehabilitation. These are all coming next. I will also be talking about the various phases of disaster management in the coming slide. So finally, it comes about relocating the people, rehabilitating the people, giving them an alternate shelter, food, water, clothes. You would have observed that nowadays, when there is a disaster like flood or landslide, even in the recent example of Kerala, Wayanad landslide, the government announced, please don't send used clothes. Uh, it was because these kind of rehabilitation mechanisms actually created more problems. People started having rashes. People they had a problem of discarding the unusable clothes. You cannot educate every member of the society to be so prudent and so brilliant in order to give only very very usable clean clothes. So in the excitement of helping the affected people started sending all the junk clothes what they had. And it was a way of disposal for them, and to dispose them in such a very emergency scenario in a place like a rehabilitation center was a challenge for the governments. And now that is why nowadays the government is saying please don't send uh, clothes. And finally, the upliftment of the society and the environment, bringing them back to the normal. We have numerous cases in India where the population is relocated, they are rehabilitated there, but nothing is done to the affected area. It is left there as it is. Like a classic example is Dhanushkodi, that too in near Rameshwaram. What has happened has happened. There was no rebuilding which was thought of. That is probably because of various other factors that there is enough chance of the disaster reoccurring. But notwithstanding this example, there are many examples where once the rehabilitation is done, the affected area is forgotten. Now you have to see how to mitigate a disaster. This has got four levels basically. The first one starts at a very personal level, what you as an individual can do when a disaster strikes an area. The second one could be a group level. Third one is a community level or a district level. Uh, Fourth one would be a policy level or a state level or even a national level. So personal level, you have to be prepared on knowledge of first aid, evacuation techniques, uh, and whatnot, clearance, debris clearance techniques and things like that. Group level, probably you can train a volunteer group at your institution. I think we have a very young and enthusiastic participant amongst us. The organizer, can you please mute that? Yes, I am okay. So, group level is about organized recovery or organized response during a disaster, which basically happens at a very mm, mm, formal level. For example, the police, the paramilitary, the firefighters, they are all going to respond at a group level, not as individuals. Community level, yes, you can form a disaster mitigation plan. You can first identify what disasters can happen to your own locality. It could be at an institutional level, or it could be at a locality level or a taluk level, where you can form a community. You can subdivide that community into various response units, and you can be prepared with a disaster mitigation plan. Policy level, yes, each district administration and state administration and the national administration has got a lot of uh, what do you call, a lot of policies or programs which are already devised to help in disaster mitigation. So I would again emphasize you to study the Odisha model and also the Gujarat model for such information. This is what I was talking about, phases of disaster management. The first one is mitigation, second is preparedness, third is the response, and finally the recovery. But unfortunately, we lay more emphasis on the recovery alone in many cases. So mitigation is what is mitigation? It is actually facing the disaster, but it is more of having data of such similar disasters, predicting the effect of the disaster, or forecasting the effect of the disaster, to a certain extent forecasting the timing of the disaster, which is always a uh, humongous task, which always most of the time goes wrong. But still, there are models. I have personally experienced weather models in countries, small countries like Singapore, Malaysia, where they are able to predict the period. As it is being announced, like from 1:53 p.m. to 2:04 p.m. you will have rain. It rains exactly in that period, which means their forecasting models are very good. I learned from a recent interview with a key person in the meteorological department. He says we don't have enough models in India to predict thunderstorms or rainfalls. Uh, and you would be surprised when you go through the data of especially Orissa. You have a significant percentage of people dying out of lightning or thunder strikes, which means if it had been predicted and a forewarning had been given, people could have stayed in a safer environment rather than going outside. So mitigation is the most important part. Preparedness is being equipped with the required tools and resources for the response. And then thirdly comes the response, which is the action you have to take when a disaster strikes, which is about the do's and don'ts, and how you organize, who takes the lead, who will be the leader, and who will follow. All those models has to be put in place for the response. And finally, the recovery or the rehabilitation of the affected people, that will solely depend upon the magnitude of the disaster. So finally, to conclude the first part of my presentation, if you have to, I've made this acronym to make it easy for the student. This is an overall bird's eye view of disaster mitigation. You have to design systems to eliminate damages or loss of life. So that D stands for design to eliminate. I stands for innovate to minimize the cost of such designs. There could be designs, but if your community or if your government cannot afford to spend that, then there is no point in making the design. So there has to be innovative methods through experiments or through synergizing with cross departments. You can always minimize the cost of the design. S stands for surveillance, which is creating the data. So, for example, we have seismography stations, which will alert the authorities immediately whether this could trigger into a landslide or an earthquake. I mean, or a tsunami or something like that. So, surveillance is also very key for disaster management. So DIS alertness to initiate action. So you have received the information, but are you ready to observe it? There are a lot of, for example, the Bhopal gas tragedy. Uh, Information was there, but people were very careless about it. They were not alert enough to evacuate the place immediately, and therefore we ended up in a very bad situation. So alertness is important. The support system readiness, for example, we are talking about floods, we are talking about inflated rafters, but if the rafters are uninflated or you don't have the compressors to uh, uh, inflate the rafters, then also you have a problem. So the alertness is very important. Support system for the action is also very important. Then comes the time of response. Mostly this happens in case of fire accidents. If your fire engine is not reaching on time, then you have a problem. Every second lost is actually exponential impact, has an exponential impact on the life or the damage to the life and the property. Then about this is about evacuation procedures, and finally about the rehabilitation models. So disaster management is on a whole is starting from design and ending with the rehabilitation models. If you have an action plan for all this DISASTER, then I think you can become experts of, or you can become leaders of disaster management. Now, in the second half, what I am going to talk is about earthquake resilient structures in the urban scenario. The organizers had given me a cue to talk more about a disaster in the urban scenario. And more, I am talking about earthquake because I am majoritarily talking to civil engineering group because it is organized by the Department of Civil Engineering. But I also saw one or two participants who are out of this domain. So I will try and keep it as generic as possible. I will not go into formulas or things like that. The information will be very generic so that anybody can understand. If some of the participants are not able to get into the crux of the matter, you can always note it down and you can interact on that particular slide during the interaction section. So what is an earthquake? It is a sudden movement in the Earth's crust, the outer crust, due to various reasons. It could be because of the movement of tectonic plates. It could be a local failure or a fault failure due to mining, etc. But earthquakes are always accompanied by release of energy in the ground system. So they actually shake or roll or vibrate the Earth's surface, and this vibration is going to affect your built environment, your structures, and there will be a lot of response from the structures for the earthquake, which might even be catastrophic. When the structure starts to collapse, then we are facing more probability of loss of many lives. So earthquakes are considered very dangerous. I will also share some case studies where I had to face an earthquake hit zone face to face, and whatever we have learn from that. I will share it with you. So these are some fundamentals of earthquakes. You would have read it. You are all teaching faculty, but I will not go through this very deeply. But just to recoup, just to pull up our socks, the focus on the epicenter are some important parameters or important jargons which we talk when you talk about earthquakes. Focus is the point from where the energy starts to release. It is the point within the earth where the faulting or the movement begins. It is also called the hypocenter. And the point on the map on the surface of the earth, which is directly above the focus, is called the epicenter. So the epicenter is on the map, wherein the focus is inside the map or below the map, inside the earth's crust. So you often have seismic waves when an earthquake is initiated. The waves are primarily divided into body waves and surface waves. Body waves you have P and S waves, and in the surface waves you have the Rayleigh waves and the Love waves. Let's see what are these waves looking like. The primary wave and secondary wave, as you can see in your screen, the primary wave is a longitudinal movement. It is like the compression expansion. You could have seen children's toys, spring, very popularly used by children. When you shake it, you can find zones of compression and expansion. This is the mode of movement of primary waves. And for secondary waves, you actually have the sine wave kind of a movement. This is actually wavy. This is what we more often relate to a wave, but we should understand that the primary waves are also waves. So these are two kinds of body waves. Okay, the primary waves are the fastest because it is moving only longitudinally. There is no lateral movement. Secondary waves are slower than the primary waves. They are popularly called as P or S waves. Now you have the Rayleigh waves, which is a combination of P and S waves, I would say. And Love waves will have P and S waves, but will also have a translational movement. It will have a vertical movement and it will also have a translational movement. I don't know who named it Love waves because it is the most dangerous wave an earthquake can produce. It is going to affect our structures more predominantly, but somehow they have named it as a love wave. But these are the most damaging waves during an earthquake. So what happens during an earthquake? Of course, the ground will shake. Sometimes the ground will fail. Sometimes it will trigger a tsunami. Many a times it will trigger a fire because of short circuiting of electrical conduits, etc. Sometimes it can lead to flood when the earthquake will hit a dam or a check dam or places like that, or a reservoir per se. It might lead to a secondary effect of landslides. You can have electric shocks. You can have any other accident by fall of an object, by fall of a furniture on you. And these are all the effects which an earthquake can create. So, what are the factors affecting an earthquake damage? It is primarily the building configuration or the shape. If you have a non-friendly shape of the building, then the damage is going to be higher, which means there are friendly shapes or earthquake friendly shapes available for a building. We'll talk about this in the upcoming slides. And the number of openings in a building, the size of the openings in the building, the orientation or the placement of the openings in the building could be an important factor in amplifying the earthquake damage or mitigating the earthquake damage. The rigidity distribution in a building, the structural rigidity, the sizes of the columns, the sizes of the members, what you are providing. You cannot have a too rigid area and a very soft area. For example, the stilt floors of multi-storied buildings are called as soft floors. This is bad as far as an earthquake is concerned because the rigidity of that floor is low, wherein the rigidity of the other floors is high. So these are some of the factors which could amplify or reduce the effect of earthquake damage. Ductility per se is a very important concept. It is the gap between the initiation of the yield and the failure. So ductility is the ratio between the yield point and the failure point. So this aspect, when you don't achieve in buildings, even with enough uh, what you call enough cost which has gone into the building, you will not be able to mitigate an earthquake properly, because the most primary requirement in making a building is giving time for its occupants to evacuate. When you start feeling an earthquake, you should have adequate time to evacuate, so that even small failures in the building will not affect human lives. So ductility is a very key factor which will support this cause. Of course, the type of foundation, the soil on which the foundation is resting, these are also factors or causes to uh, vary the earthquake damage. And finally, yes, construction quality. Whatever design you make, whatever innovation you make, if it is not implemented properly at the site, at the construction site, you are likely to have more damages during an earthquake. So these are some of the possibilities of land displacements during earthquake. You can have a slip, you can have a reverse slip where one part goes over the other. You can have a lateral slip, which is called the strike slip. You can have the oblique slip, which is all both vertical and the horizontal movement of the landmass. This picture explains how an earthquake can trigger a tsunami. These are fundamentals to be understood. So when an earthquake strikes and there is a normal slip, then what kind of tsunami will be created? When there is a reverse faulting, what will happen? So that is what this picture is showing you. It is very obvious that when an earthquake happens in an island, the energy starts flowing through the sea, and finally you feel the tsunami only in the coastal area. Till such time, the tsunami has long waves but small amplitude. So they don't move vertically upwards or downwards. We need not assume that the large waves, what we call in Tamil as Ari Peralai, this will happen only in the coastal shelf, the continental shelf, not in the deeper areas of the ocean. But even though it is there, the energy starts moving. That is why uh, the ships are not the ships which are in the deep sea are not affected by tsunamis, because it is not accompanied by a vertical wave. The rally wave is not there in the deep sea. It happens only in the uh, continental shelf, or rather in the coastline. This is a picture of 2004 Indian Ocean earthquake and the related tsunami. This was pictured from Sri Lanka, I believe. So, what happens during a tsunami or during an earthquake? Mm, there are some cracks which appear on the structure. Partially, there will be collapse of the masonry units. You can have falling of the spandrel. Spandrel is the portion between your lintel and the roof. So you can have spandrel failures, you can have corner separation of walls, you can have the roof collapse, partial or full, you can have the roof beams alone collapsing, you can have the complete failure of structure. I am talking to you with the perspective of non-engineered buildings, the fundamental buildings which are populating most of the urban areas. Fortunately, the high-rise buildings or the multi-storied buildings are often engineered by a competent person, and it is being approved by a competent authority. And so it has got, I would not say 100% good, but it has got a reasonably good amount of checks and balances. For example, if we recently submitted a 16-story building to the LPA for approval, they only checked the planning parameters and they referred the design to PWD and Anna University. So those authorities started questioning us on various technical parameters such as participation ratio, the kind of load cases we have subjected the building to. All these questions were there. So after answering and after satisfactorily answering all these questions only, we were able to get the mm, approval. But this happens in most of the engineered construction. But urban areas are not majorly with engineered constructions. Maybe 10 to 20% is engineered, but 80% are non-engineered, meaning at least it has not been engineered to withstand earthquakes. So that is where these kinds of failures are happening. I am going to show you a case study at what happened at Bhuj, uh, where we had participated in a rehabilitation program. Now, coming back to the basics of the earthquake, in India, we have decided, we have categorized the land map into, earlier we had classified into 5 zones, which means zone 1 to zone 5, based on the severity of the probability of the severity of the earthquake. It's only a probabilistic zoning, but it was there. But now zone 1 has been merged with zone 2, which means there is no single plot in India which does not have the risk of earthquake. The entire country is having a risk. Should I stop? Okay. The entire country is having a risk of earthquake, starting from zone 2 to zone 5, zone 5 being the most critical or the most harsh. So this was the earlier map what India had. You can see most of the uh, zones in the Deccan Plateau and the South India were only up to zone 3. We had zone 4 only in the northeastern part or the Himalayan belt, and few in the Maharashtrian and the Gujarat zones. And the entire northeast was in zone 5 earlier. But as we started getting more surveillance data, more data about the fault lines, more data about the tremors which are happening, then we had changed the uh, seismic map like this. So you can see a phenomenal shift. But this is only a map. It is done on a map. Only the colors have changed or the contours have changed. But still, the information is more or less true. So once you encounter something, encounter a design in such an area, you have to make proper precautions. Coming back to the basics, this is the principle in which the seismograph is working. So you have a freestanding lumped mass which actually creates a pattern of the earthquake on a rolling sheet of paper. The earthquakes are measured on a Richter scale, starting from 4 to 8. Anything below 4 is not considered as an earthquake. It's called a tremor. But today morning in Delhi, I learned that it was in the scale of 4.3 Richter. So it's a minor earthquake what we actually experienced today morning. So from 4 to 8, it is classified as a minor earthquake, moderate earthquake, strong earthquake, major, and a great earthquake. Now, I am going to talk about certain scenarios where the developed countries are using. See, what happens is the most important point in the design of an earthquake resistant um, building is the challenge is to estimate the natural frequency of the building. So you have lot of formulas, lot of calculations, lot of forecast and assumptions which will help you to calculate the natural frequency to some number. But have we ever checked these against real earthquakes? No. Only God knows what happens when a earthquake strikes. There is no mechanism in place to actually measure this. But what developed countries have done, especially I'm talking to you from models from China, they have installed sensors in in many tall buildings, and they started uh, collecting data of the performance of the buildings, and they are feeding those data into AI models. You can see this is a collection of data of the response to buildings for vibration. This is done over 200 existing buildings. You can see based on the structural height, which is depicted in the y-axis, you can see the fundamental time period. See, for example, from 150 to 250 meters, the fundamental time period is somewhere between 2.5 seconds to 6 seconds, those red dots. And beyond that, you can see it is the fundamental time period starts somewhere around 4.2 seconds to maybe up to 9 seconds. So this is a very reliable model, because it is not based on some formula alone. It is based on actual data, actual conversation with buildings. Now this is where the structural engineering world is getting into. We install data loggers, and we actually study the real response of building rather than predicting a theoretical response of buildings to certain mm, earthquakes. So we now need to understand the difference between a damage versus a disaster. So when you design a very good earthquake resilient building, it doesn't mean the building will not get damaged at all. There are damages in buildings. There are allowable damages in building, or damages are allowed to a certain extent so that they don't affect the life of the inmates. Uh, you cannot have a zero damage building for an earthquake. So the idea is to allow certain damages, and I will give you a beautiful picture later, where we saw in the Bhuj earthquake, there were mm, parts of a prison, parts of a fort which was used as the prison. But when the uh, earthquakes struck, uh, most of the urban infrastructure was gone. A lot of buildings collapsed, but the fort did not collapse. Only the outside walls of the prisons collapsed, which we thought probably it was designed so to allow the prisoners to escape during the earthquake. So it was so brilliantly designed. So I can show you the picture of that fort also later. But the point I'm trying to make here is, on an engineered building, you have a lot of well-established models like the seismic coefficient method, response spectrum method, time history analysis. I was just talking about the AI-based performance analysis. So the performance-based designs are becoming more reliable nowadays. But the plight of the non-engineered buildings, the G+1, G+2, single-storied buildings, is very bad. So the plight of the non-engineering buildings are what you have to be very prepared about. You have to prepare your students about the fundamental knowledge of doing such buildings, uh, which doesn't require a rigorous analysis of earthquake. It just requires a proper detailing of the structure, or proportioning of the structure to mitigate small earthquakes or minor earthquakes or moderate earthquakes at least. So there is a complete set of guidelines available. These are available over the net also. The fundamental, I'll for want of time, I think we have another 15 minutes only to go before we start the interactive session. So I will try to be a little bit fast, because all these informations are already available over the net. I can send a copy of the guidelines for earthquake resistance of non-engineered buildings. See, in this picture, what you say, this is a typical one-storied tiled roof building, a pitched roof building, where an earthquake can strike because earthquake force is the energy is traveling through the landmass, the land is shaking, but the force comes from inertia. Earthquake is not externally coming and applying a force to you. It only shakes the ground, and because of the inertial forces of the building, of the mass of the building, the building experiences forces. So you can go through the index. 1 represents the earthquake force, which is not like the way it is depicted in the picture. It looks like as if a wind load is coming and hitting the building. No, it is, this force is available everywhere throughout the building, in every single grain of sand in the building. So it is necessarily a inertial force. Number 2, the portion which is above the lintel but below the roof is called the spandrel masonry, because this is a very critical area, because spandrel failure is one of the most fatal failures, because this will lead to or precipitate into a roof collapse. So spandrel is there. Sill masonry, this is like parts of the building. Number 5 is the critical section for bending cracks, because lintels, if they are not provided as a through lintel, or if they don't have enough bearing, then the building starts collapsing at the openings, which is a critical section. And number 6 is the vertical load, which is the gravitational load of the building itself, which is shown in the picture below. 7 is the horizontal force, which happens in each element. 8 is the overturning moment, because all your spandrels, the piers, number 4, which is the pillars between the openings, starting from the sill level to the lintel level. This will act as a hinge, because it will crack up easily and you will have an overturning moment. And the 9, 10, 11, 12 depicts the various stress patterns which can happen in various elements of your building. So once this information is digested properly, I think you will be able to design or mitigate it through design, by providing proper materials and precautionary measures to prevent those failures. This is again where the cracks could happen, where the various types of cracks on a non-engineered building. You can see the propagation of cracks always starting from the corner of openings. That is why earlier I told the positioning and the distribution of openings is a key factor in amplifying or nullifying the effect of an earthquake. So what happens during an earthquake? Maybe large buildings can collapse, flyovers can fall down. It doesn't mean that just because they have very, very robust or big piers, they will not collapse. These are very, very vulnerable structures, because they always have a pendulum effect. The piers are too slender when compared to the kind of load they take on their top. This is a classic example of the pendulum effect. A collapse of a multi-storied building, failure of the landmass, partial collapse. You can see in the picture to your right, major portion of that block is intact, wherein the escape route has collapsed. The staircases have collapsed. But it is very, very important for us to design and detail the staircase very properly in an earthquake uh, possibility zone, of course, in all zones, because those are the lifelines. You cannot obviously use the lift or the elevator when an earthquake is happening. So you have to escape through the staircase. But if the staircase is so carelessly designed, detailed, or executed, then you have a problem. Again, staircase collapse, uh, complete collapse of structures or partial collapse of structures. This is Gujarat after the Bhuj earthquake. This happened in urban and semi-urban areas. You can see a lot of tiled houses which have gone to the mud. You can see the quality of masonry built there. I have circled it, the kind of careless construction methodologies or construction practices. Of course, these all makes it, though earthquake is not man-made, the damage is man-made. The amplification of the damage is also man-made. This is because of careless construction practice. You can look at the orange circle. You can see the beam is almost having a minimal bearing with the column. The green circle shows how unevenly the lateral ties of a column are provided. So it is all because of wrong design, wrong detailing, or wrong construction practice. That is the point you have to take forward or drive through uh, to the students. You can see a clearly separated wall to your right because it doesn't have the proper bonding techniques followed. When there is a when there is a right angle turn, you are supposed to place the bonding in a particular manner, which we teach in the basic construction practice, the English bond, Flemish bond, corner detailing and all. But unfortunately we don't emphasize on that. Again, a picture of how poor brickwork led to a failure. You can see the crack development right from the openings. So it is important for us to design the uh, masonry around the openings very carefully. I was part of ACC Siemens by then, so we had the opportunity to be a part of the earthquake relief work. This is a retrofitted structure. We have repaired the damages, and this was used as a training center to train the localites for self rehabilitation. This is part of the town called Motichirai. This is the fort I was talking about. These forts had parts of only partial collapses there. If you look at the second floor, you can see partly collapsed area, but most of the fort was intact. So in masonry buildings, you have uh, mostly tensile and shearing stresses which damage the structure because it is very good in compression probably. So we have the cracking and overturning of parapets, cornices, all the overhangs, basically all the cantilevers will easily get damaged. You can have occurrence of falling of plaster. You will obviously have cracking of walls. You can have cracking and falling of ceilings, and you can have damage of glass panes, furniture, appliances, etc. So for the benefit of the non-engineering participants here, I think we will not get into too much of this. Anyhow, I'll share this information with you. But there are various types of cracks and failure models which you can encounter in a uh, building during an earthquake. I will come to the basics, the do's and don'ts. Fundamentally, the plan has to be symmetrical. The plan of the building has to be symmetrical. It should have a regularity of the shape. It cannot have a very crazy shape or a zigzag shape or a skewed shape. It has to be circular, rectangular, or square. It should have proper separation of blocks. It should be a simple plan, not with lot of recesses inside, because these are all areas where the energy will concentrate and do more damage to the building. I'll show them through examples. You can see an L-shaped building and a rectangular building here. The moral of the picture is the rectangular building is more safe than the L-shaped building. You can see various shapes. B is non-desirable. A is desirable. Either you can have a square or a rectangle with a central opening, or an I section with a small projection. Wherein in the list B, you have a long rectangle. I already showed you some pictures of some apartments which were long rectangles which collapsed. So it should not be long rectangles. It should not be unsymmetrical. It should not be an eye with long projections. It should not be an U-shaped building. It can be as far as possible. If you have designed it so, then you have to take proper precautions in the structural systems to mitigate this stress concentrations. So what you can instead do is, if you need to have a long building, you can separate it into fewer blocks and still make it appear like a long building. You can isolate the blocks and then you can design them as simple shapes. So again, these are some techniques where you can reinforce the corners of the walls. You can have a proper jointing mechanism between wall to wall. I'm not going to deal with or elaborate all these things. These are basic information provided in the do's and don'ts guidelines. You can download it from the NEERI website. It is already there. So these are some detailing. What you need to understand is there is a proper detailing mechanism available in case of reinforced masonry. Even for RCC structures, or the reinforced cement concrete structures, there is a detailed guideline given in IS 13920. So the code book 13920 deals exhaustively with earthquake detailing. These are some examples of uh, reinforced masonry buildings, but which are very, very earthquake friendly or earthquake resilient. These are techniques through in which the corners of the buildings are reinforced, but it's a single rod, but it offers tremendous ductility to the building. It doesn't allow the masonry walls to separate because you have provided enough banding, bonding, and anchoring of the joints. So these are some simple techniques through which you can achieve uh, earthquake friendliness for buildings in the urban scenario. So mostly the failures, what we observed from the Gujarat experience was uh, the drawings itself themselves were not prepared with adequate details. So the drawings were handicapped. They didn't have enough details, and those details were not translated into execution. Whatever details they have also was improperly translated as execution, and therefore we had more damage. So it is very, very essential to position the reinforcing bars when you make a structural drawing. The positioning of the bars should be very accurate. The cover thickness should be specified. The development length should be specified, uh, and adequate provisions of the code books 13920 should be complied with. The very fundamental of bending the bars itself is mostly ignored in many sites. The code says if you have to bend a bar to 90-degree when you make the normal bar bending, if you have to bend a bar of diameter x, you have to use a mandrel of diameter 4x. But unfortunately, in sites, for all the diameter bars, we use the same mandrel, which will result in very sharp curves. It will take the steel to the yield point very easily, and therefore it is very likely to fail. We also have a habit of mixing up of two different grades of steel. This is actually going to promote bimetal corrosion, and there will be many areas of weakness which we don't know because already inside it might be corroded. So when an earthquake strikes, the precipitation of the failure becomes very rampant. uh, so we take less care in positioning the lap joints. All the joints are lapped in uh, the same zone, and this slide is very important because most of the RC buildings in Bhuj collapsed because they lacked this tie, the horizontal tie in the beam column junction. Your bar bender always tries to avoid this because it's a little bit more effort for him to put this tie. But if this is not there, be sure that the joint is going to collapse. So this is a very important emphasis. This is a very important culture that the younger civil engineering society should imbibe. And always a beam column joint should have a horizontal tie. Again, this is a very famous formula, very important formula, the development length. But lot of places the development length is conveniently ignored. Therefore, we end up having less anchorage, or the bond strength being developed, and therefore there are a lot of collapses. So I leave it to you. These are all covered in IS 13920. The do's and don'ts about earthquake detailing. So I would like to skip this part for the want of time, but anyhow I will send you this information through the organizers. But nevertheless, this is all covered in IS 13920, the detailing part of uh, the reinforcement in an RCC structure. So I will come to some important generic principles. See, many a times the detailing is done so theoretically that you don't have space to pour concrete or put the vibrator. So what happens practically at site? People tamper with the design. They move the positioning of the bars and they start concreting. They don't give enough chairs for the different layers of reinforcement, but they keep walking on it. Therefore, you will lose the position of the bar. It will bend, and therefore you will lose lever arm. Therefore, you will lose the moment of resistance of that structure if it happens to be a structure designed or the element designed for uh, flexural stresses. This is a classic example of how a well designed, well executed staircase of a mall failed because the detailing was not done properly. This staircase failed and we lost 2 lives because the anchorage was not done properly. If you can see there, the anchorage reinforcement of the waist slab of the staircase actually got pulled out, and you can see how it has got pulled out. It has to be anchored on the other face, inner face of the beam, but it wasn't done so because of inadequate detailing and inadequate translation of the detail. This failure happens. You can see nicely how the bars have been pulled out because they didn't have enough concrete around them to hold it. So this is one more collapse where the positioning of the bar was done wrongly. It has to be done like this, but it was just like that, bent and made as a cantilever. But when the cantilever was de-shuttered, we had this collapse. We also have carelessness in maintaining the health of the rebars, which are left for future expansion. Look at the damaged rebar, corroded enough, and it's already deteriorated enough, but we sometimes it is being ignored, and the construction is being continued, and then we end up in disasters. This is the failure of the quality management system in a construction. You can see certain parts of the structure don't have concrete at all. So similar example, look at the quality of concrete there. You don't have enough fine aggregates. It's a very coarse matrix what you find there. In a structure, we saw that a part of the column was missing because probably mud was filled there, but nobody cared. They started executing the plinth beam, and this discontinuity was there. But when the working loads were present on the column, the structure started to fail or deform profoundly. So very inadequate detailing of expansion joints. You can look at the rebars of the plinth beam, which is just protruding, which has not even gone into the column. Uh, this is not cut, believe us. When we did the investigation, when we opened up the joint, we found that the beam reinforcement is just hanging in the air and it has not been taken into the column at all. Again, an example of quality of concrete. This is some retrofitting work which we have done after noticing the negligence which has already happened. These are cracks at sill because of uh, inadequate detailing, poor quality of concreting. Look at the cover thickness. Sometimes somewhere it is very less, somewhere it is very high. Again, an example, misalignment of columns. So the moral of the story of these pictures are that we, the engineers, are actually culprits. Look here, just to support a fabrication system, they have conveniently cut the bottom rebars of a beam. And how do you expect the beam or the structure to behave properly? Another example, very common, they have punched through the beams wherever necessary. Probably those are toilet sewage lines. I am able to guess it because uh, there you have the ventilators, not the windows, and you have punched through the beams, and you never know whether those were designed for taking those sleeves. This is non-maintenance of structures. This will also lead to disasters many a times. Lot of high-rise buildings or office buildings will have terraces, especially the government buildings will have terraces which are not visited at all, and they will have more or less a shabby look. So the moral is you will all have to be very vigilant or sensitive to detailing issues, especially when it comes to mitigation in earthquake scenario in in an urban environment. So though we talked a lot about the general principles of disaster management, as civil engineers, we understand the importance of planning of the buildings in proper simple shapes, designing of the building with adequate knowledge of the forces which will act on the building, detailing of the building with background of the uh, code practices or code recommendations, execution of the construction with proper um, good construction practices, and maintenance of the building with proper care and with an eye point of or a viewpoint of the damages which could precipitate into a uh, what do you call disaster or a partial or a full collapse of the structure. So with this, I would like to thank you all for the patient hearing, and I would like to uh, hear from any of the participants if at all you have um, something to share or deliberate or exchange. I'm okay to take questions. I think we have another 5-6 minutes to go.
Good evening, sir.
Good evening, sir.
Sir, as you have said that these are the defects that we can see in our buildings. I have seen these defects in day-to-day life. That is, rebar are open for the future construction, and concreting is not done properly. Cracks were there. Sir, if these are done already, then how can we mitigate that? What are the proper procedure to do it properly after it's happened?
Yeah, there are two perspectives to it. There are local repair techniques. Basically, once it has been done and you observe a local deficiency, there are techniques like grouting. You can do carbon wrapping. You can provide additional supports. You can have anchor bolts to support the junction between masonry and RCC. These are all basically repair techniques which are used for retrofitting. But on a design level, if you find an inadequacy, still you have a scope. You can do a retrofitting by bracing. This is getting popular, especially in case of institutional buildings. you can use anchor fasteners and externally brace the buildings. You can provide bracings externally without doing any changes to the internal walls or the internal structure of the building. So you can provide external bracings through which you can still make the systems very robust. So it depends on how carefully you will analyze, how you will actually quantify the effect of deficiency or the damage. So if it is local, you have a set of practices. If it is on a design scale, then you have probably you have a chance of still mitigating it through external bracing, or a combination of the common repairs and the external bracing.
Okay, sir. Thank you very much. It is a very, very interesting system.
Thank you so much.
Dear participants, any more questions? Sir. Sudhakar sir.
Yes, sir. My mic was switched off. I'm sorry.
Yes, sir. Sir, I think the question sessions we can able to complete now, sir.
Yeah, we can. If at all there are some questions, they can write it on a message to you. You can send it to me. I'll try to answer them before these
Okay,
6
sir.
days.
Okay, sir.
Yeah.
Okay, sir. Dear participants, we will be sharing the today's chief guest mail ID to you through the WhatsApp link. If any questions, you can directly
No, I would
send
suggest
email.
they can write to the organizer. You can.
Yeah. Okay, sir.
Because I cannot take multiple questions.
Okay, sir. Okay,
Maybe
sir.
4
Okay,
5
sir.
participants will have the same question. So
Okay,
you
sir.
will
Dear
list it out
participants,
and
you
you
can
send it
mail
to me.
us. You can mail us either to me or to the Dhamesh sir. You can mail us. We'll be sending the queries to Dr. Sudhakar sir, and we will get the inputs. Thank you, Sudhakar sir, for your wonderful speech and wonderful session on disaster management. Today's session has been started with the disasters, how the disasters has been occurred, causes of disasters, and AI applications in disasters. Thank you very much for your wonderful session, sir. Thank you, sir.
I hope all the participants enjoyed it and they will continue enjoying
Yes,
this.
sir. Most of the
6 days.
participants has benefited through your valuable session, sir.
Yeah. Let us not make
Thank you,
this
sir.
FDP a disaster.
Sure, sir. We enjoyed a lot, sir, your session. Thank you, sir.
Thank you, ma'am.
Thank you, sir.
Thank you, sir.
Thank
Dear
you all.
participants, you stay back in this link. The next speaker will be joining in the five more minutes. We will be sorting out your issues. Sir, thank you very much, sir.
Can I leave, sir?
Yes, sir. Yes, sir. Thank you, sir.
Thank you. Thank you all. All the best.
Thank you.
Thank you,
very much,
sir. Thank you so much.
Sir, sharing.
Thank you. Thank you, sir.
Thank you, sir.
Thank you, sir. Sir, wait a minute, sir. Thank you, sir.
Dear participants, you stay back in this link. The guest will be joining in 5 more minutes. Dear participant, wait for 5 more minutes. There is a network issue in the other side.
Hello. Am I audible now?
சரிங்க சார் வந்துட்டாரு சார்
Sir, audible, sir, audible, sir.
கூப்பிடுறேன் சார் அடுத்த
Okay,
சீக்கிரம்
okay.
ஸ்டார்ட்
Really sorry, some technical glitch.
ஓகே சார்
No
I
problem, sir,
changed
no
my
problem, sir.
browser. Now it's
இப்ப
working.
பார்த்தா தெரியல நான் கூப்பிடுறேன்
No problem, sir.
ஒரே நிமிஷம்
Sir, just a minute, sir.
Okay, okay, please.
பிரசன்ட்
Sir, 2 minutes, sir.
Okay, okay, please take your time.
Sir, PPT share ஆகுதான்னு பாருங்க sir. Sir, can you able to share the PPT, sir? Sir, can you able to share the PPT, sir? Yes, yes. Yes, sir. Full screen mode. So in full screen mode. For audio. Okay, sir. Okay, sir. Screen is sharing, sir. Sir, பேசுறது கேக்குதுங்களா? Sir, are you audible, sir?
Yeah, are you able to hear me now?
Yeah,
Yes, sir.
we are able to hear you, sir.
Okay, sorry, I kept in mute.
Okay, so just 1 minute, sir. I will give a small
Okay,
intro, sir.
please. Okay, please take your time.
Dear participants, sorry for delay for a short delay for the second session. The second session is on the topic of applications of remote sensing and GIS in disaster risk management by Dr. C. Gajendran, Associate Professor, Department of Civil Engineering, SNS College of Technology, Coimbatore. A short brief about Dr. Gajendran, sir. Dr. Gajendran is accomplished an academician and researcher with over 24 years of experience in civil and environmental engineering. He holds PhD in civil engineering from Anna University, Chennai, along with master degrees in environmental engineering, and in additional 2 diplomas in rail transport management and industrial safeties. Currently, he serves as a professor and senior innovator at SNS College of Technology and a domain expert for the ICFRE under the Ministry of Environment and Climate Change, Government of India. His extensive professional experience include teaching and administrative roles at Cornell University and other prestigious institutions, as well as hands-on industrial experience as a design and site engineer. Dr. Gajendran has served as several government-funded research projects, securing over 122.14 lakhs in grants for the studies in hydrology, GIS applications, forestry research, and smart city initiatives. He has also been actively involved in the consultancy, contributing to the water supply management, sewage system, renewable energy, and heritage conservation, generating a total fund of 70.30 lakhs. His research contributions include numerous Scopus Indus Journal articles, book chapters, and conference papers focusing on water resource, disaster resilience, and urban planning. Additionally, he has filed multiple patents related to water conservation, waste management, and engineering innovations. Overall, Dr. C. Gajendran is a distinguished educator, researcher, and consultant dedicated to advancing civil engineering education, sustainable infrastructure development, and environmental resilience through innovative research and academic leaderships. The forum is open to you, sir. Sir Gajendran, sir,
Thank you.
Now.
Thank you, sir. Thank you for the opportunity. I don't know how many of you finished your dinner and what is in your mode. It is really happy to see you people online. The 155 participants still awake and they are eagerly waiting for the lecture, right? So before starting, I just want to say something. So at any point of time, you please raise your hand or you can unmute and you can ask questions. So you don't need to wait for the end so that I can also feel live. Okay, so it should not be a single communication and I want a more interaction. Okay, yes, today I'm going to cover, I have divided my lecture into majorly 3 parts. One is how the basic things, how we can use the remote sensing and GIS technology for disaster risk management, then followed by some case studies, and then time permits, I can show you some lights on how we can use the free open source softwares and open source data for our modeling or whatever the needs you are having. I hope my audio is well. I can continue like this, right?
Yes, sir. You'll continue, sir.
Thank you. Okay, thank you very much. So before starting my lecture, I just want to have making some understanding how good you people are in GIS. Okay, let me post this one. I think my screen is visible. You just scan the screen, or if you are not able to, just go to joinmyquiz.com. Okay, so or else I can paste, copy paste in our screen in chat box. Okay, so you people Okay, your chat box is not working, sir. Actually, it's a permission
I
given.
will, yes, sir, I will try to solve it that problem, sir.
Okay, no problem.
WhatsApp
If
group
you are
is
able
there,
to,
sir. WhatsApp group is there, sir.
yeah,
sir,
then
go
I'm
for
not in
full
the
view for, yes, sir. Tell me, sir.
Yeah, actually, I do one thing. I shall share you in your WhatsApp. You please share with the people. This is to basic understanding how people know about JS, so that I can tune my what do you say, my lecture in such a way that it is easy to you people. 1 minute. So I have shared you the link in our WhatsApp group. You please put it in your workshop group. This is a small exercise where we can understand what is how much GIS you know, so that I can keep my presentation to fit with the people. Ramesh sir, are you able to share, sir? Yeah, I can see one participant joined.
Wait a minute, sir.
Okay,
I will
okay.
share the links to that group, sir.
Okay, please.
Yes, sir. Share the link to that group, sir.
Okay, I request the participants to join and answer. Try to answer some question. Attempt. It is. We are not going to conduct any exam for now. This is to understand purpose only and keep you live. Yeah. You can see the name who all are joining now. Okay, another 30 seconds, I can start the queues. Okay, let me start the queues. Thank you. Thank you for your active participation. I really appreciate all of you for your active participation. And these questions are mixed questions. It will not only check your basic as well as it will have a mid-level and the high-level questions are there. Still, I really appreciate you people participation. And now we shall move to the topic. Today we are going to discuss on the topic application of remote sensing and GIS in disaster risk management. Mostly I'm going to cover on Indian aspect as a case study. I hope today you have got some knowledge about disaster. Okay, so what is disaster management, by the way, or disaster risk management? It is really a systematic approach which involves identifying, assessing, and reducing the risk associated with the disaster. So we have to identify, then we have to give magnitude, how much it really happened, and then we have to plan in future. It should not happen or we have to reduce the risk in future. So all together we call as a disaster risk management. For that, we need the thorough knowledge on the current scenario, what is happening, then the history, what is happened, then where it is happened and how it is happened, all those information. When where the question where come into the picture, the best tool is actually, or any spatial information come into the picture of any technology or any technique, the best tool is GIS and remote sensing. So these disaster risk management include planning, preparedness, response, and recovery activities. What is the role of remote sensing and GIS in disaster risk management? The remote sensing and GIS have a vital role. Actually, it will, we need to, as we know that to have the disaster management, we should have the real-time data on hand. As I said earlier, we should have a historical data and then the real truth of the information. So real time means suppose any disaster is happening on that particular time, what is that, what is there on the system, or what is there on the space, or what is there on the particular location is important. Then we should have what is the history. Okay, so based on that we can take the decisions to handle the situation. And the remote sensing will give you the real-time information about the Earth surface. So you are using different types of airborne devices to have that monitoring system. Some devices are on Earth, some devices are on floating on the air. So based on that, we will get the information on real time. What is the importance of remote sensing and GIS in India? In India, the significance of remote sensing in GIS in disaster reduction management, risk management is amplified to this continuous vulnerability. As you know that India is having all kind of disasters. There are the possibility of flood, cyclones, earthquakes. So this technology helping us to handle the situation, plan for the future. What is remote sensing? Remote sensing is referred to the acquiring the information without having any physical contact with the object. As we are in dinner time, in some houses, your people will prepare some food. Without going there, you may be sit in front of your laptop or mobile or your pad, whatever it may be. Okay, so but that dinner preparation will disturb you through your nose, right? So that is a kind of remote sensing. Without having any physical contact, you are able to identify some object or some information, then it is called the remote sensing. So what are the types of remote sensing? Majorly we have optical, radar, thermal, lidar. See, these all are the major remote sensing which is used for our disaster management. Okay, radar which uses microwave signals, and the thermal detects emissions or by emittance, and lidar which measure the distance using laser light and to create the high resolution maps. Nowadays the lidar cameras are there, even our iPhones are coming with lidar camera. What is about GIS? So there are two main components for managing the disaster. One is the remote sensing, another one is the GIS. Whereas the remote sensing is the data acquiring tool, and GIS is the tool which is used to sort the data, manage the data, and get the interference out of that. The geographical information system which have the elements of hardware, software, data, human resources, all those things together, we will capture the data, we store the data, we analyze, and we manage the spatial data to get some information or to make some decision. So to make some decision, to get some information, or to manage some situation, we need different types of data, what we call in GIS environment layers. So data layers in GIS represent different thematic data sets over geographical location. They can include layers for topography, land use, infrastructure, and demographic data, enabling comprehensive analysis for disaster planning and management. So these data nowadays are freely available, especially for disaster management studies or disaster management. The live data are supplied by the in world level and then the local level or in regional level. Spatial analysis in GIS. What do you mean by spatial analysis? As I said earlier, we have different types of information which is put together. We call it as a layer. So this layer can be useful or can be used to get some analysis. So what kind of analysis we can do? For example, in a particular area, is there any possibility of flood? So as we know that, so if your place is below mean sea level, there is a huge possibility. That too, if it is in a low lying area or in a depressed area, there is the huge possibility. How we can know that? Using this spatial analysis tool, you can know how that things are present on the earth, how it is in, on what pattern it is presented, and what trend it is presented. So this will give you the spatial distribution. Then this will give you the information about the particular area where you can make some decision out of that. Then the modeling in GIS is the next level, where you will do the modeling from the real world information, so that you will predict or you can simulate what are the disaster scenarios. As you know, suppose if you want to study about landslide, then we have some n number of possibilities or scenarios. So then if you want to study about earthquake and its effect, or if you want to study about flood and its effect, any other disasters, there is the possible, there are scenarios, right? So as I said, and as an example, if you it is the flood, the flood normally will go with the depressed area on your land, and the two which is below the mean sea level or sea surface. So there you have to have the scenario of what is the RL, reduced level of that particular area, then what are the nearby water sources, what are the nearby highest places. All those information will help you to do the modeling. The modeling will help us to simulate the situation or to predict. Suppose this much has happened in the earlier time, so using the same scenario, same historical data, you can predict for the future scenarios also. Now we can move on to the application in disaster risk management. So pre-disaster phase. So the pre-disaster phase involves proactive strategies to mitigate the risk. Risk assessment, identify vulnerability, hazardous mapping, visualize the threat, and early warning system alerts communities to impending dangers. So actually, we have different phases in disaster management or to reduce the risk. So some disaster we cannot control because it is in nature hand. It is because of our last few years, our practices and our system, what we are following. Because of that, this kind of disaster is happening. We cannot say we can control the disaster, but there is the tools and methods where through which you can easily control the disaster risk. So to control or mitigate the risk, you need to have the vulnerability. What are the area there is the possibility of vulnerability? You can have hazardous mapping, so which will visualize the threat, and the early warning system which will alert the communities. These all are possible by means of the remote sensing and GIS. For instance, suppose there is a fire on a particular area or particular place, even it may be a forest or it may be on land or in urban environment, you can inform the people that how they're supposed to move. If for example, say for example, some flood happened on a particular area. In that flood, if you want to know how the people, who is the nearest person whom we supposed to inform, and how we have to evacuate the people, all those things are possible using this GIS and remote sensing tool. Even during the COVID time, I had my own experience working with the people of government agency, where we have doing the geofencing. So what if most of you, I believe that most of you know what is geofencing, right? So we need to have, as we experienced during the COVID time, we have to demarcate some places where the people should not move from one place to another. So at what basis we demarcated is by basics of the number of people affected by COVID. So we will block the particular area, and we can inform the local authority and government to block that area by using the geofencing system. This is such an example where we can have our real-time information on data. If you work with that spatial information with the map, then it will be easy and possible. Next one is the risk assessment. So the risk assessment evaluate the potential hazards and vulnerability within the region, enabling informed planning and resource allocation. Okay, so risk assessment is, this is the next level. How much risk is there on particular area? So for example, some area may have some low level area, low lying area, but still there is the less number of possibility for the any kind of risk because of other factor which will enable or which will help them to reduce the risk. Actually, remote sensing data provide a comprehensive analysis, enhancing the accuracy. So when compared with the other methods, based on, suppose if you're only going with some historical data based on the local people's knowledge or something, there sometimes which will mislead. What I'm trying to say is, suppose some area that people say, so prolonged time this is happening in this area, something like that. So because of government initiative, because of some natural changes, there is the possibility of the risk or that kind of a particular disaster may not happen on the particular area, reasoning with some more examples. So what will happen? So it will reduce, that particular area maybe get reduced, because if you have a live data like remote sensing, this will give you the more accurate assessment. Another application of our remote sensing is the hazard mapping. So we have to identify and visualize the area where more hazards will be there, and we have to give the information to the stakeholders where they're supposed to move. For example, in a particular area is affected by flood, we are facing it in Chennai, or you can take anywhere. So you have to inform the people where they're supposed to move. Suppose there is a sudden flood on a river, so you have to identify the places where the people are supposed to move. So it is not saying that there is the rain, there will be a flood, something like that. You have to give information to the people where they're supposed to move and where they will find that safe place. So that will be possible in live time based on the remote sensing data. So for that, every as we know, or you must know that every district administrator is having a map, what is called hazards map or disaster map. All those information will be there, where they will give the information to the public, or they will inform the local authority about that thing. Suppose something happened in a particular area, even nowadays they are scaled down up to ward level. So what is in a ward or in a particular panchayat, they have identified some people, that people are the first contact people. So they will inform that people, and then that first contact people will inform to the other people. So like that, through the community, we will pass the information. This is the top bottom-up approach. Another one is the top-bottom approach, where that disaster information will be passed to the collectorate or the authorities. Next one is the early warning system. So the early warning systems utilize the remote sensing data, forecast the disaster, and issue alerts. So before in hand. So earlier time, the people normally say that even through the animal and the what is that movement of air, all those things they are able to identify. Nowadays, as we disturbed the birds and animals, they are also not able to give that much accuracy, or we are not able to sense it like our forefathers. So nowadays we have some technology to using our remote sensing and GIS, through which you can find the early warning system by using sensors and all. So when the sensors give the information, it will be processed and it will be cross-checked before taking the decision or informing to the people. During the disaster also, our remote sensing and GIS is having very important role. So real-time monitoring combines satellite data, ground reports to the assess disaster impact instantly. This data aids emergency responders, making informed decision, optimizing the route and the resource, and saving the lives. So it will inform the people where it is really it's happening, what are the places where the people got stuck and they need really the help. It may be food, or it may be shelter, whatever it may be. This real-time information is possible based on the two things. One is the real-time satellite data, And another thing is ground reports. Ground reports in the sense the topographical data, the population data, and then this men and material movement data, all those things, which will be combined with this remote sensing and GIS environment, which will help us to identify the places where people really need such help in the real time. Emergency response planning. So as I said, in real time, we have to give the information. To give information in real time, we should need some emergency plan. So emergency response planning. So where they're supposed to go, how you are going to communicate. So even during this time, you might have, it will be affected by electricity will not be there, and then communication will not be there. Still, how you can respond it. So that emergency plan can be made in such a way that it is integrated with the real-time resources and by the coordination of the people, those who are in the ground. Okay, after disaster, how even our remote sensing and GIS is very needed. How it is, so to know how much damage it is given, so that it will be useful for the decision makers to have such information on hand. This will help them to identify, or this will help them to work with that information, so that they will prepare their budget, they will prepare for the future reference, all those things. These things are very important. Then recovery planning stage also, we need our remote sensing techniques and GIS. This will help us in recovery mode. Recovery mode is how the people has to move. So who is the nearest person, which is the shortest route, which is the safest route, all those things will be identified and planned by using this remote sensing and GIS techniques. And decision support system, because we are in the emergency situation, right? So during that emergency situation, we supposed to have we are supposed to take some decision which should be accurate, which should be very cost effective, and which should give the real-time information, as well as it should give save the life of the people. So to make such a decision, we need a technical supporting system, and we should be scientifically proven, and we should not have any ambiguity on that. For that, we are that remote sensing and GIS technique is very important. Some of the case studies from India. Some of the satellite data sources, I kept that case study separately. So now we shall move to the satellite data and sources. What are those available? So ISRO's RISAT provide all-weather surveillance, while CatroSat focuses on high-resolution imagery. These are the base data which is needed to prepare the disaster management or risk management plan. Landsat satellites offer long-term data for land use changes, and Sentinel satellite supports various applications in environmental monitoring and disaster management. So GIS platform, leading platform for advanced geographical system. QGIS is the open source, which is readily available, which can be used as an open source. Google Earth Engine is the another platform where you can have a lot of global space geospatial processing, because a GIS data need more information, more server and more memory and all. So that, but it will be reduced by using, if you are using Google Earth Engine, it will be reduced. You don't need to have such a very big memory or very big system for that. So national NTMA and IMT play crucial role in disaster preparedness and response. International bodies such as United Nations SPIDER provide support for integrating satellite technologies into national disaster management system. Even you can see that most of the places you can, if you visit IMT website, Indian Meteorological Department, where they are giving the weather information free in hand for the next 5 days or for the next month. All those things are available. Limited access to up-to-date satellite data are the one of the issue. So the data should be integrated with the local governance, and it should be checked with the local governance to give the accurate result. And capacity building and technical skill gaps are the the need of the hour, because nowadays our ISRO, ISRS are giving more such a training freely, and they are giving some hands-on training for this kind of capacity building, where the more people will able to access the tool, which will help the people to have drive more on it, and to get the quick response out of that. Of course, AI and machine learning, disaster prediction are the now trend. So this AI technology and readily available algorithm are easy to use, and they are giving more accurate result than the research so far done. So they are very much handy, and there is no even a people who know to handle the GIS environment is more than enough to have this tool. So as a add-on, it is coming, and nowadays the people are using that technology. IoT and real-time sensor network are the backbone for the real-time information. Nowadays, this IoT-enabled real-time monitoring on environmental condition and disaster indicators are there. Even it can be used to know the landslide, earthquake, whatever the disaster, except man-made disaster. All natural disaster, it is very easy and possible, and the people are doing even a man-made disaster also. The movement of your weapons or movement of defense service, everything has been monitored using this real-time environment. Of course, UAV and drones are it's not only for damage assessment, even for rescue operations or during the disaster also. People are using UAV and drones to reach out the people where we are not able to move, human beings and other relevance. So let me stop here. If I have any quick question, I can take. And if you allow me, or if time permits, if time is there, I'm happy to share some more presentation on applications, case studies, and how we can use Bhuvan for it. Can I have some quick questions now, if you have anything? So what about the time? Is the time available, sir?
Yes, sir. Yes, sir. Time available, sir. By 9:15, we can have a discussion session, sir.
9:15. Yeah, that's great. From audience, can I have some quick questions? If you have anything, or whether the flow is okay, or you want me to go slow or fast, something like that.
No problem, sir. You can go ahead, sir.
Okay, that's great.
Flow is good, no problem.
Okay, thank you very much. Yeah, we have some application case studies. This is to show some light. What are the disaster happen in India and how the people managed using especially our GIS. Flood management in Allahabad, Uttar Pradesh. GIS technology play a critical role in enhancing flood management strategy. And they have improved the disaster response in flood-prone areas like Allahabad. They have the GIS-based district disaster management system they are using now. So the comprehensive GIS-based study was initiated to formulate effective district disaster management system for flood management in Allahabad Sadar sub-district. This system integrates various data layers to optimize disaster response and planning. Lively, these people are using identification of flood-prone areas. They are using ArcGIS 9.1, and they are identified some key flood area, or in other words, we can say a vulnerable area where you will have such disasters. So they have identified and demarked such places. Even after tsunami, in most of the coastal area in our India, they have demarked and they have given they have moved the settlement area. That is one such example. Even in Coimbatore also, the people are using GIS to manage the water resources, as well as even live. They are giving the live information about water supply system, and they have giving the live information about the water quality. They are planning to give water quality, but already they are giving air quality. Those who are visited Coimbatore, you might have come across such boards, digital boards, where they have integrated such information using this GIS environment, and they are giving where what is the air temperature and what is the air quality, all those things. And then effective response strategies they are having. And so because it is mostly above 90% is scientific, so most of the time we have accurate result. Flood vulnerability and mitigation in Mahi River Basin in Gujarat. They are utilizing GIS and remote sensing, and they have vulnerability assessment and mitigation strategy in Mahi River. They are showcasing powerful towards their disaster for their disaster management. So remote sensing and disaster they are employing in for that to monitor the river in real time, and they are assessing the flood vulnerability areas using this. And they have evacuation planning with QGIS. As I said earlier, QGIS is the open source software, and you have n number of opportunity to work such environment. So this QGIS, using that QGIS, they have made evacuation planning with the QGIS. So suppose what happened, how they can move by simulating flood scenarios. Before in hand, you can do this tool. You can using this tool, you can take your local area and you can demarcate such places, and using some add-ons which are ready-madely available in QGIS environment, you can simulate flood scenarios. Suppose this much rain is happened. For example, a 5 mm, say 50 mm rainfall is there in a particular area, or 100 mm, whatever number randomly you can give, and you can simulate, and you can find what are the places where it will be affected. Okay, most of the most vulnerable places, and you can scale it in a different scale. So these all are the most vulnerable area, these all are the safest place, all those things, through which you can draw the evacuation route. Suppose something happened in a particular area on particular point, how the people can move, or where they're supposed to move, and what direction they're supposed to move. So in the evacuation plan, what are the things we're supposed to have? It not only the place where you have the highest elevation, or we have the more what is that elevated place. You should have accessibility of food, accessibility for shelter, accessibility for primary health. All those things you have to demarcate, and you have to make as a layer, and you have to find the evacuation plan. This is very important, and this is the main part of using this GIS. And very importantly, community awareness initiative is very important. Using GIS data, you can educate the residents. You can show the visualization. Suppose in our area some flood is happened, or something is happened. Some, for example, earthquake is happened or something. How are they supposed to move? So that community participation is very important, and they should be aware about using the tool and getting the communication. Then impact of climate change on flood. This is very important. That can be studied using GIS. The climate change significantly influence the flood pattern in Mahi River Basin. So continuously they are monitoring, and they are giving some adaptive management strategies. So because we cannot control such natural things, we have to give the adaptive management or mitigation plan to control such things. Data integration enhance the accuracy, as I said earlier. Collaboration with local government is very important, because at the end of the day, we are going to give this data and information to the local government only. Flood hazard mapping in Magnetic West Bengal. GIS is used in West Bengal. Gangas. So the GIS techniques facilitate detailed flood hazard mapping, integrating data from satellite imagery, rainfall pattern, and topography. These are the majorly three informations we need, which is available freely using Bhuvan and all. You can directly get those data. So you can get the data from there, and you can do your areas, local area simulation. For simulation also, you can use this QGIS based add-ons, or even our Bowen and a few more websites or data sets, open source websites are there, web-based GIS we call it. So using that web-based GIS, you can simulate the local area and you can identify where you have the risk and all. So you can know how much in Gangas, how it will be used, then everything they have made. Landslide, as we know, very aware about this happened in 2024. So they have made satellite image resulting in comprehensive damage assessment inside the infrastructure impact. So this is one of the beautiness here. Suppose some area we may not move, or we may not have data about the settlement. So such a best example is this Kerala landslide. Okay, so this place, what happened is we don't have much data. Because of this area is a forest area. Another reason, the tourism is developed in between that time. So they have a lot of changes in the land pattern, especially land surface. So they have removed most of the greenies or forest, and they have new settlements. And you might have read a lot of things in newspaper. But the informations, whatever they recorded, it is not authenticated. So really how much it happened, how it happened. So that is studied using the satellite images. Using this earlier data, 2024, previous data has been studied. And we have identified some of the settlement were there, which is not recorded in any government records and all. The reason is these places are shown as the tourism place, where they have settled in a different pattern. So which is not in that. So that it is that result shows that some of the 200 buildings are displaced, and numerous resettlements are taken place. So then they have identified using this remote sensing data. Another thing is lightning strike monitoring in jargon. Jargon they are using to monitor the lightning strike. So which will give the real-time alerts, enhance the community safety. So where they have fixed some sensors and monitoring system in the what do you say, in the mountains, and they are using GIS technology they are monitoring, even to monitor bridges, flyover and all. Nowadays they are using GPS and some sensors, and which being monitored GIS kind of software. Even using BIM, the people we are able to monitor, or we are able to monitor the in real-time system. Real-time storms can be actively monitored using community and other thing. In Odisha, they are using GIS tool to monitor cyclone. So they have the monitoring tool which will be monitored in a real time, and suitable information will be given to the local community. And resource allocation and rehabilitation can be done using these GIS techniques after post-cyclone time, because we don't know the things, real-time monitoring, and then the fast data will help us how we can move about it, and we can know how we can identify the most affected area and who is the really needy people are there. All those things can be done. Other GIS application, disaster management, draft monitoring, and is we can done draft monitoring. We can identify we have that green index values. Using this green index values and all, you can identify how much area is affected, how we can go for the water conservation. All those things can be planned. Then draft, what are the areas that are really draft affected, even the government to make the fund available. We should give the information about it, how much area is being really affected, how much area is being wedded, all those things, information is there. Earthquake risk mapping in Gujarat is done using GIS. So you can now, we have the information, based on the information, you can now, we have hazardous vulnerable map. And you can give the guidance. As we know, as a civil engineer, I think most of the people are from civil engineering background. You know that earthquake structures are entirely different from earthquake resisting structures are entirely different from other structure, normal structures or whatever it may be. So for that, we should know the places where you're supposed to have this such design and such attention is needed. Urban flood management in Mumbai, as we know very well, Mumbai is known for its flood, especially in the season area, monsoon seasons. So they have used GIS to have the real-time monitoring, not only monitoring, to give the evacuation plan and minimizing the infrastructure damage, all those things based on that tools and techniques. Forest fire monitoring is in Uttarakhand, the people are, in India, we are doing. So Uttarakhand, as you know that their forest fire is monitored, and based on the other factors like wind and the draft area and the dry area, based on that, they give the information about how they can outbreak yearly fire. Let me quickly give some light on Bhuvan. Actually, those who are really interested in working with GIS and remote sensing, it is really easy and it is very interesting because most of the data and the tools are freely available. Bhuvan serves as a web-based GIS. So GIS can be divided in different ways. For working purpose, we can divide into broadly two. One is the desktop GIS, another one is the web-based GIS. Desktop GIS is, you can work with your GIS with your system or computer, whatever you're having. Web-based GIS, where it will be in the web browser. You don't need to have any system or any, any memory or whatever that sophisticated software, anything is not required. Only the thing is you should have a good quality of web server, or you can say, rather you can say internet connection. Then that is enough to work with the GIS. Such platform is the Bhuvan, where you can do most of the, I can say most of the your GIS operation in real time in with the account what you have created. It is one of the initiative by ISRO under NRSC, National Remote Sensing Service. It includes the research. So you can have your own, login, and you can work on that freely. And if you are from government agency or government, then they are giving a privilege to access most of the data. And for research purpose, nowadays the people are giving most of the data are available, or you have to write to the Bhuvan from that website. There are form is there. Using that, you can have that. You can mention what is the purpose and application. Then they will give you the access or data in a free hand. Key features of them, it have the high resolution satellite imagery, high resolution satellite image, and then which can be used for the applications of like disaster management, urban planning, agriculture, environmental monitoring, and most of the decision making things can be done. Even nowadays, it's coming with 3D visualization and terrain analysis. Even now that Google Earth is updated, the Google Earth is the your front end of GIS. Whatever you're seeing in Google Earth, you are checking for the nearest place for your restaurant, or nearest place for anything, or shortest route for your navigation. All those things are in the back end. GIS is there. In front end, whatever map you are seeing. And land use, land cover pattern can be done. Customizable map and tools. Bhuvan offers customizable maps. So this is one of the thing you can do. You can demarcate your study area like this, and you can take the data. It may be your soil data. It may be your land use, land pattern, land use, land cover change, or it can be any data for this demarked area can be obtained and you can work on it in real-time environment. So in disaster management, Bhuvan, how it is using, Bhuvan enable real-time disaster monitoring by providing access to satellite imagery and geospatial data. This is very, very important. Suppose even I'm working with the local and other government and private agencies people. So where suppose it happen even during that Kerala flood time also, we have obtained some information and we have helped the people directly and indirectly. So these real-time data are very much helpful to take the decision and to give information to the authorities, those who are really working on ground. So we sit in our office and we will work on that map and all, and we are giving information, and that people will help them. And we can use this data for pre and post disaster assessment. So this is very helpful. So for example, the government may claim some number and the local people claim some number, some area where the flood is affected or where it is vanished, something like that. So this can be done scientifically. It can be accessed using the pre and post disaster assessment, where you can have evaluate the damage and who all are really in need. This can be done using this post and pre disaster time. And as I said earlier, evacuation route can be done using Bowen in real-time environment. And it will give the coverage of various disasters, support the wide range of disaster scenarios, including flood, cyclone. So actually you can select, we have a number of this kind of all, mostly all the disaster variants will be there. There you can select your, what is the interest and your study area, and you can work on it. Even you can have, you predict what will happen. Suppose some more rainfall is there, some earthquake happened, or some landslide happened, how it will be. For example, you are living in a mountain or hilly area where there is the vulnerability of landslide. You can use this tool and you can have the idea about how it will affect. Suppose a landslide happened because of some reason or other. It may be, as you know, that we have different types of landslide. It can be by flood, what happened in Kerala, like that. So that is also possible. It is real time, you can do that. So not only for disaster, even you can use this Bhuvan application for urban planning also. So the urban planning, you can have monitoring, or you can have the infrastructure development, or you can predict the population growth or the pattern, urban, how the urban is developing. All those things is possible. In agriculture, agriculture monitoring and the farming system and the crop monitoring, yield estimation we can do in agriculture using this Bowen platform, using soil moisture level, and we have different scenarios to work on it. And forestry and environment, so you can have information about forestry. Bowen track the deforestation changes in forest cover, which is essential for biodiversity conservation. It monitor air and water quality while supporting afforestation initiatives, provide crucial for environmental sustainability. Water resources management, Bhuvan provide hydrological data essential for river and watershed. Most of the river watershed, even micro level watersheds, are being delineated by Bhuvan. And you can, if you are working or studying in water resource management, it is possible, you can go for it. Rural development also, Bhuvan is having a major role. You can use it. Climate and weather monitoring can be done. And the defense and security system also there people are using for Bhuvan. So in future they are having come up with some, they are integrating AA and IoT sensors and all. Yeah, let me stop here to take some questions.
Participants, if you have any queries, you can feel free to ask.
Professor, very good evening.
Yeah, good evening. Yes, sir.
Actually, for disaster kind of things, they are using the remote sensing GIS data for pre and post analysis.
Yeah.
Is there any specific methods to find the disasters before occurring it?
Before. Yeah, we have such a tool that is called vulnerability mapping. So where you can have the assessment. Suppose a flood, for example, if you take flood, you can assess it before in hand. Suppose this much rainfall is there, well in before you can get the information. As I said, we have some IoT enabled sensors and some techniques through which now we are monitoring landslides and other what do you say, that disasters. That is possible.
Actually, you have talked about the Wayanadu landslide.
Yes, sir.
We can able to find out the how much land deformation is happening over the period of years.
Yeah, that is possible.
And then we can predict before occurring the landslides. Why we have not done it, those things?
Actually, that is the thing. That is that gap between the policy maker and the, what you say, politician and the people. This is a triangle, rather I say. Already it has been warned that they are cutting down the tree. I think you might have come across the scientific reason behind what is happened, right? Actually, they have cutting down a lot of trees. Okay, so it happens so that these trees are the trees are because of, and they have settled, they have constructed new buildings. So the trees are the tree roots are the what is the anchor which keep the soil in position. Okay, but what happened is suddenly they have removed the tree. So once the water enter into this thing, so it water into the soil, so it move like a slide. Okay, it's like a sheet, like it's moved.
Yes.
Because of that only we are not able to. It is already actually informed. There is the see, even I don't know whether you have heard about the E-flow, environmental flow. You know, no? Environmental flow, in that scenario, there is the thing. There is the particular year a flood should be there in the river. In a particular time, there should be a low flow should be there. Like that, some scenarios, scientific scenarios are there, which supposed to be follow. What happened is we are showing we are calling that as a controlling factor, and we are controlling that flood is not good for science.
My question is why the government is not done for the land deformation studies?
They are doing actually.
But the prediction is not that much.
That's what I'm telling. See, actually, two things are there. One is already the policy had made, and they should not cut down the tree, and they have to preserve all the forest area. All those things are there. The people are not followed one. Secondly, and the rainfall is suddenly have occurred. It is not predicted that rainfall this much will happen. What they are expected is in a different scenario. So they have, based on the earlier report, they have identified if the rainfall happened also they can control. But what happened suddenly is a different scenario. Actually, as you rightly said, they are the monitoring system through which they are controlling all those conservation plan. Everything is there, but still the people are destroying the nature ahead.
That's what the landslide was occurred.
Yeah.
Okay. Thank you. Thank you.
Okay. Thank you.
Participants, do you have any more queries? Any other participants? Dear participants, if you have any queries, sir, I hope there are no more questions, sir.
Okay.
On behalf of K.S.Rangasamy College of Technology, Department of Civil Engineering, myself sincerely thanks to Dr. G. Gajendran sir for accepting our invitations and given the valuable insights of the today's topic, applications of remote sensing and GIS in disaster risk management. SARS has given insights on various inputs like Bhuvan and QGIS and AI applications in disasters. Thank you very much, sir, for accepting our invitation and given a very good lecture, sir. Thank you.
Thank you. Thank you for the opportunity. One more time, I thank all the participants and I wish all people a successful completion of this workshop, this program. And one more time, I thank Dr. Ramesh and the team and the management of KSR for this opportunity. Thank you, sir. Thank you very much.
Thank you very much, sir.
Okay.
Thank you, sir. Thank you so much, sir.
Thank you.
Dear participants, sir, you can leave, sir. Dear participants, tomorrow we will be sharing the link. Mostly the same link will be sharing. And the feedback link also will be posted at the earliest in the group. Thank you very much. Kindly join 10 minutes earlier before the session starts.
Thank you, sir.
Thank you, sir. Thank you very much. The meeting has been officially ended. We will meet by tomorrow. Thank you very much for your actively participation in today's sessions. Thank you very much.
Sir, one more question.
Yes, sir.
Hello.
Yes, sir. Venkatesan, sir. Yes, sir.
Yes, sir. Is it mandatory to mark the attendance in the WhatsApp group?
No, sir. In WhatsApp group, it's not mandatory, sir.
Okay.
Dear
Okay.
participant, there is no need to send in the WhatsApp group as I am attending like that. There is no necessary, sir. We will be downloading the attendance through the Teams and we will be updating in the Atal portal. You can check it in the Atal portal by tomorrow morning. Yeah, sir.
Meaning that I couldn't able to make login.
So no, sir, there are some issues in the directions because morning yearly session many are attended.
Okay.
There is no issue, sir.
Okay, sir. Okay. Thank you.
And there is no need to post the attendance in the WhatsApp group, sir. Thank you, sir.
Thank you, sir. Thank you.
திருநெல்வேலி